students. Today we are going to discuss about aromaticity from the paper CHO 4103, that is Basic Organic Chemistry, section first. So friends, in my last lecture we already thoroughly discussed about aromaticity, and we know that for the aromaticity or for the compound to be aromatic, we need that compound cyclic, planar, fully conjugated, and also the pi electron must be in the 4n plus 2 fashion. So the any compound of cyclic, planar, fully conjugated and obeys 4n plus 2 pi electron rule is called as aromatic. Few examples we have discussed. They are benzene, pyrrole, furan, thiophene, cyclopropyl, cation, pyridine, imidazole, oxazole, pyrimidine, and naphthalene. In this lecture, not only aromatic but anti-aromatic and non-aromatic compound we will discuss. We will differentiate aromatic, anti-aromatic, and non-aromatic compounds. So friends, let's discuss about anti-aromatic compounds. So what are the anti-aromatic compounds? Anti-aromatic compounds are similar like aromatic compounds, but they only differ in the number of pi electrons. That is, anti-aromatic compounds are compounds which are cyclic, planar, fully conjugated, and have 4n pi electron systems. So the compound which have 4n pi electron system, cyclic, planar, and fully conjugated, it is called as anti-aromatic compound. For example, you can see here, this is a cyclopentadienyl cation. So what is the criteria for aromaticity or anti-aromaticity? It is a cyclic, planar, fully conjugated, and how many electrons are there? Pi electrons, only 4 pi electrons. Therefore, this is a anti-aromatic compound. Now you can see here, this is a epoxide ring. We can see that the oxygen lone pair and this double bond are involved in the delocalization. So there are 4 pi electrons. So this small ring is cyclic, planar, even fully conjugated, but only have 4 pi electrons. That's why it is called as anti-aromatic compound. Similarly, all these compounds, especially you can see here, this is a cyclobutadiene. This is cyclobutadiene having 4 pi electrons. So it is a cyclic, planar, fully conjugated, having 4 pi electrons. So it is anti-aromatic compound. So in next slides we will see more examples about this kind of topic. So let's go for the non-aromatic compounds. So before we go for the non-aromatic compound, let's differentiate between the aromatic and anti-aromatic compounds. So what are the aromatic compounds? Compounds which are cyclic, planar, fully conjugated, and having 4n plus 2 pi electrons are aromatic. For example, benzene, pyridine, and naphthalene. In this paper, we are going to discuss more complex example. These are very common examples of aromatic compound like benzene, naphthalene, pyridine. Okay, so these are the basic concept for the aromatic compound. What are the anti-aromatic compound? They are cyclic, planar, fully conjugated, but having only 4n electrons. So 4, 8, 12, this kind of electrons, and cyclic, planar, and conjugated compound is called as anti-aromatic compound. So this is what we learn. These two examples what we learned in the previous slide. So these are the difference between aromatic and anti-aromatic compounds. Let's go for the non-aromatic compound. Friends, non-aromatic compounds may break any three of the first three criteria. What? They may not be cyclic, may not be planar, may not be fully conjugated. So if they are fail in above three criteria, it doesn't matter whether they obey 4n or 4n plus 2 pi electron rule. So non-aromatic compounds are compounds which may not be cyclic, may not be planar, may not be fully conjugated. So they can obey 4n or 4n plus 2 pi electron rule, doesn't matter for us. So you can see here the first compound is not cyclic, definitely it is non-aromatic. Secondly, it is a cyclic planar but not fully conjugated or not conjugated, though it is a non-aromatic. Secondly, same, it is not fully conjugated, therefore it is non-aromatic. Fourth one looks a straight chain compound and it is not cyclic, so this is called as a non-aromatic compounds. So friends, the very common example about non-aromaticity are the 8 and 10 membered rings. So due to the macro cyclic rings, 8 and 10 membered ring cannot hold the all atom in one plane. Therefore, the 8 membered ring is tough shape, and due to this internal hydrogen repulsion, this cyclodecapentine also not planar. So cyclodecapentine 10 membered ring, due to non-planar nature, it is a non-aromatic. Similarly, cyclooctatane also non-aromatic because it is not planar. So this is the summary for aromatic, antiaromatic and non-aromatic compounds. What are the aromatic compounds? Cyclic, conjugated, planar and obeys 4n plus 2 pi electron rule. Antiaromatic compounds are cyclic, planar and conjugated but having only 4n pi electrons. Okay, 4n pi electrons, that means 4, 8, 12, 16 and so on. So what are the non-aromatic compound? They fail in any one of the three criteria. The fourth one is 4n plus or 4n rule of pi electron doesn't apply for them. So these are the this is the summary for the aromatic, antiaromatic and non-aromatic compound. Now friends, let's start with the smallest ring system, that is a three-membered ring system. Now you need to help me to identify whether the compounds are aromatic, antiaromatic or non-aromatic. Let's start with this first example of cyclopropane. So what is cyclopropane? It is aromatic, antiaromatic or non-aromatic. So you can see here it's a cyclic, planar but no conjugation, therefore this compound is of course non-aromatic. It is a cyclic, planar but no conjugation, no pi electron, so it is a non-aromatic compound. Okay, now what about the cyclopropene? We have one pi electron but this carbon is left behind or it is away from the conjugation, so this is also not fully conjugated, therefore this is also non-aromatic. Now let's go for the third example, that is a cyclopropyl cation. So due to this positive charge, now there is a full conjugation over all the atom. So what is how about this compound? This is cyclic, planar and fully conjugated, also have 2 pi electrons, that means it is obeying 4n plus 2 pi electron rule. Here n is 0, n should be any whole number, so we can take 0 as a whole number. So 2 pi electrons are also in the magic series of 4n plus 2 pi electron system. And how it is fully conjugated? You can see here. This positive charge can be delocalized due to the movement of this pi bond. Okay, if this pi bond shifted over here, positive charge will be on here. If this pi bond shifted here, this positive charge will shift over here. So all the three carbons or all the atoms in that ring getting conjugation. That's why it is fully conjugated. That's why it is a aromatic. Okay, how about the last one? You can see the last one is cyclic, planar, fully conjugated but having only 4 electrons, that is 2 from this double bond and 2 from negative charge. So it having 4n electron, 4n pi electrons, therefore it is nothing but it is an antiaromatic compound. Now let's go for the 4-membered ring. Can you tell me the first compound? Of course it is cyclic, planar, but no conjugation, therefore it is a non-aromatic. Second is cyclobutadiene, cyclic, planar, fully conjugated, but having only 4 electron, that is it is obeying 4n pi electron rule. That's why it is a anti-aromatic compound. The third example is asked in CSIR NET examination. It is a cyclic, planar, fully conjugated, having 2 pi electron, that is it is obeying 4n plus 2 pi electron rule, therefore it is aromatic. Okay, and the third compound is aromatic because it have only 2 pi electrons, that is it is obeying 4n plus 2 pi electron rule. Now the last one, last example, having 4 pi electron and it is cyclic, planar and fully conjugated due to positive and negative charge, but due to 4n pi electron it is anti-aromatic and not aromatic, therefore it is called as anti-aromatic compound. This is how we are going to discuss about 5-membered ring systems. So the first one is, of course, it is a non-aromatic. How about second? Most of my students confused between whether this compound is fully conjugated or not. Friends, you can see here, for the conjugation we already studied. In layman's language I will say double bond, single bond, double bond, single bond, again double bond. So there is two singles bond beside each other, that means it is not fully conjugated. There is no other charges which are connecting these two pi bonds at this carbon. Okay, so this carbon is left behind from the conjugation. Therefore, due to lack of fully conjugated system, this compound is of course non-aromatic compound. Okay, and it contains 4, 6, 8 electron, doesn't matter for us actually. So it is non-aromatic compound. The next compound having positive charge, now these two double bonds are connected and this compound became fully conjugated. But even it is cyclic, planar, fully conjugated, it have only 4n pi electrons. It is not following the Huckel's rule of aromaticity, that is 4n plus 2 pi electron system. So this is not a 4n plus pi electron system, 4n plus 2 pi electron system. It is only a 4n pi electron system, which is cyclic, planar and fully conjugated. Therefore, this is an anti-aromatic compound. The next one looks like aromatic because it have 6 pi electron. It is a cyclic, planar, and I also have a fully conjugated system. So the last one is aromatic. Okay, because it is cyclic, planar, fully conjugated and having 6 pi electron, 2, 4 and 6 pi electron. Therefore, it is aromatic compound. Okay, it is obeying 4n plus 2 pi electron rule. This is how we are going to discuss about the anti-aromatic, aromatic and non-aromatic compound. So friends, if you are enjoying, let's go for the 6-membered ring system. So very complicated, or I will say very simple, but most of the time it is very confusing for my students to identify whether it is a fully conjugated or not. So we will discuss few examples from this slide or 6-membered ring system. So friends, I will say up to 7-membered ring system it is a planar, but from 8 onwards it is not a planar ring system. For I will say 8, 9, 10 and 11-membered ring system are not planar. Again, if we go for the macrocyclic ring from 12-membered ring, it is again getting planarity. So only we have problem with 8, 9, 10 and 11-membered ring system. So that part we will discuss in the next few lectures, but let's focus on the 6-membered ring system. So first one is of course is a non-aromatic compound. How about the second one? It's anti-aromatic or non-aromatic? Anti-aromatic or non-aromatic? It is cyclic? Yes, it is cyclic. It is planar? Yes, it is planar. Is it fully conjugated? No, it's not fully conjugated. That means it is going for the non-aromaticity, because after that we are not going to consider about 4n or 6, 4 or 6 or 8 pi electrons. Okay, so this is straightforwardly non-aromatic compound, the second one. Now how about the third one? It is cyclic planar fully conjugated. No, it's not fully conjugated, that's why it is again non-aromatic compound. How about the fourth one? It is cyclic planar fully conjugated. No, this is the CH2 over here. Even some of my student confused with the 6 pi electron system. Friends, 6 pi electron system comes after it is cyclic planar and fully conjugated. It is failing in the conjugation rule, that is, it is not fully conjugated. If we draw the resonance hybrid, we will draw the dotted line up to here. From here, this CH2 is away from the conjugation, or not even wholly in the conjugation. That means all the atoms in the ring are not getting conjugation or pi electron density. That's why it is a non-aromatic compound. Okay, this is non-aromatic compound. And how about the last one? Okay, the world famous example of aromaticity, that is benzene. It is cyclic planar fully conjugated and also having 6 pi electron, that is 4n plus 2 pi electron in the ring system. That's why the last compound, the benzene, is aromatic in nature. Friends, this is all about today's lecture. In the next lecture, I will again come with a few more complicated or complex problems related to aromaticity. Especially, I will cover the problems from CSR, NET and SET examination. So, for today's lecture, if you guys have any doubt, please feel free to ask me. Thank you very much.